So in the last lecture, we have discussed the Darbox mean value theorem. Okay, so what is the Darbox mean value theorem? Abhay. Give the statement of Darbox mean value theorem. Abhay, can you hear me?
Yes, sir.
Yes. So what is Darbox mean value theorem? So see, Darbox mean value theorem is nothing but is an intermediate value theorem for differentiation. So suppose you have given function f which is differentiable. F is defined on closed interval ab to r. Okay, and lambda is any number between f dash a and f dash b, then there exists some c belongs to open interval ab such that f dash c equal to lambda. Okay, so last time we have discussed this result. Recall that suppose f is a mapping from closed interval ab to r, which is differentiable function, and lambda is any number, real number between f dash a and f dash b, then there exists some c belongs to open interval ab such that f dash c equal to lambda. Okay, so this theorem is known as intermediate value theorem for derivative, or Darbox mean value theorem, or simply Darbox theorem. Okay, so this is a important result. Okay, the name of this result is okay. An intermediate value theorem for continuous function is something like this. Suppose f is a function which is from closed interval ab to r, continuous. Okay, then f assumes every value between its maximum and minimum. So wait a minute, let me share again. See. So f into r, which is continuous, then f assumes every value between its supremum and infimum. That is, suppose m equal to supremum of f, or infimum. Capital M is equal to supremum of fx over closed interval AB, and small m is equal to infimum of fx over closed interval AB. And if you take any number between small m and capital F, and if you take lambda belongs to small m to capital M, and you can find out there exists C belongs to AB such that, or closed interval AB, you may take here also, you may take here closed interval. It may happen that okay, so this is intermediate value theorem for continuous function. So these things we have discussed in the earliest lecture. Okay. Now today we are going to discuss some examples. Okay. Here not closed interval. Let me take here. I think here open interval. Yes. So here I should write open interval, not closed interval. So this is intermediate value theorem for, or in more general, you can also take in this way. Or if take any number between f of a and f of b, or let me assume that fa not equal to fb, and lambda is a number between fa and fb, then also you can find out there exists some c belongs to open interval ab, so that f of c equal to lambda. So this is intermediate value theorem for continuous function, and this is intermediate value theorem for differentiable function. Okay, so both are very important. Okay. Now let me take some examples. Okay. What is inverse function theorem? The third one is a very important result is inverse function theorem. Abhay, tell me inverse function theorem. Do you remember inverse function theorem for differentiation?
नहीं सर नहीं याद है.
You should remember all the statements, because in the examination they ask something like this: state and prove inverse function theorem. State and prove something. State and prove something. Okay, so roughly speaking, inverse function theorem is, suppose you have given f from closed interval a b to r, which is differentiable, continuous, and 1 1, and differentiable at x0. Or differentiable, let me take on continuously differentiable. Okay, and let us assume that f is 1 1, such that f dash x is not equal to 0 for all x. Okay, then we have proved that f is monotone, isn't it? In the previous lecture, see, I think we have dash x is non-zero for all x, and f is this is the statement. We have seen that f is monotone and y0 equal to fx0 suppose, then f inverse is differentiable and its derivative at y0 is equal to 1 upon f dash x0. Do you remember this? So this is the statement of inverse function theorem. Let me put some examples. L'Hopital rule also we have seen. Very good. Examples creation in the function theorem. I'm looking for examples, not theorem. That is monotone. And yes, this is the statement. F inverse dash y0 is equal to 1 upon f dash x0. Now let us see some examples. What is f dash x0 actually? X0 is nothing but, let's see from this. See, look at this example. For n belongs to n, and suppose n is odd, and let me define function f from R to R by fx equal to x raised to n. This is a polynomial function. Okay? then what can you say about differentiability of function f? Is f differentiable? Okay.
Sir.
Yeah. Okay. Now the first question is f increasing? Where is f increasing? Okay. Is f increasing?
होगा सर.
Why? What is derivative by the way?
N x raised to n minus 1.
Okay. Now, since n is odd, n minus 1 is even. Therefore, for every x belongs to R, x raised to n minus 1. This is the even powers of x. So this is always greater than equals to 0. Like n minus 1 may be 2. So here powers are like multiple of 2. X square, x raised to 2, x raised to 4, x raised to 6. So in all the cases, in general, x raised to n minus 1 is always greater than equals to 0. Do you understand? Therefore, n into x raised to n minus 1 multiplied by n, this is also positive. But n into x raised to n minus 1 is nothing but f dash x. This is greater than equals to 0. And if its derivative is positive, therefore f is increasing on. Now is f11 second equation increasing? Okay. Is f11? By the way, how can you show that some
हाँ सर.
why it is 1? Give me the reason.
F fx1 is equal to fx2. सेम करेंगे तो x1 is equal to x2 मिलेगा.
That is true, but how can you say it is 1 1? Can you say from this? See,
सर आपकी आवाज बहुत कम आ रही है. कभी कभी तो आ ही
बहुत
नहीं रही.
धीरे से आ रही है सर आपकी आवाज.
yes, okay, now?
हाँ अभी आई.
Okay, okay. Now I am asking you, is f11? The answer is 1. So how can you show that some function is 1 1? So in this way, you need to show that f is 1 1 if and only there are two ways beginning from for all x1 x2 belongs to R, begin with f of x1 equal to f of x2 implies you must have to show that x1 equal to x2. This is the first way. Or second way is this: for all x1 x2 from R, suppose x1 not equal to x2, Okay, then P implies Q is true, then not P, not Q implies not P is true. This is P and this is Q, and this is true if and only if not Q. So what is the negation of Q? X1 not equal to X2. If I take two different points from domain, I must have to show that their image is also different. Do you understand?
Yes, sir.
So let us prove by this. So let X1, X2 belongs to R with, let me assume that X1 not equal to X2, and also without loss of generality. Since by trichotomy law, either X1 is bigger than X2 or X1 is less than X2. So without loss of generality, let me assume that X1 is less than X2. Now since F is increasing, here already I have proved, increasing on R, you can say that F of X1 is less than F of X2. Or in short, Fx1 and Fx2 are different. By the way, it is strictly increasing here. Okay. So
Yes, sir.
Fx1 is not equal to Fx2. So we have begin with x1, x2 belongs to R and x1 not equal to x2, and we have proved that fx1 is not equal to fx2. Therefore, you can say that f is 1, 1. Do you understand? Hello? Do you understand why it is 1, 1?
Yes, sir.
So because of this reason, f is 1, 1. Fine. So f is also 1, 1. Now, next thing is this. What can you say about f of R? What is image of R? F of R equal to R, or simply you can say that f is onto. So f is invertible in short. You can show, one can show that uh, its image under R is equal to R. So f inverse exists, and f inverse is also function from R to R. And what is inverse function? So how can you find out inverse function? In this way, fx equal to y if and only x equal to f inverse y. So fx is nothing but x raised to n equal to y if and only x equal to y raised to 1 by n, but x is nothing but f inverse y. So what is your f inverse x? What is the definition of f inverse x? Wait, f inverse x is given by x raised to
I raised.
1 by n. Do you understand?
Yes, sir.
Clear?
Yes, sir.
Fine. So this is inverse function, f inverse x. You may say this to be gx also. Now, what is inverse function theorem? See, I want to just show you application of this inverse function theorem. Okay, so f inverse derivative of f inverse y0 at y0 is equal to 1 upon f dash x0. Okay, तो अभी आवाज ठीक से सुनाई दे रही है ना?
हाँ सर।
ओके ओके। और यहाँ पे देखिए, we are looking for derivative of inverse function d by dx of f inverse at x, f inverse at y0, f inverse x। ये कैसे होगा? ये देखिए, एक्चुअली यहाँ पे अगर y in terms of, if you write y, then you should write here y. Okay, this must be equal to 1 upon f dash of, what should I write? See, in general, let me do it different way. We assume that x is not equal to 0 for time being. So if x is not equal to 0, and what is dx or derivative d by dx of f inverse x is f inverse x. So we are looking for derivative of this. So what is f inverse x? F inverse x is nothing but x raised to 1 by n. Okay, and this is nothing but uh, derivative of f inverse x. Okay, fine. This is equal to, according to our rule, f dash of f inverse x. See, what is inverse function theorem? x0 is nothing but, what is x0? You can write in this way also. x0 यहाँ से क्या आएगा? If you understand, so you can write in this way, f dash f inverse y0. Okay, so what should I write here? f dash f inverse x. Since here x, यहाँ पे क्या था? देखिए, यहाँ पे y0 था ना, that's why I have written here y0. अगर यहाँ पे x है तो मुझे क्या लिखना चाहिए? यहाँ पे x मैंने लिखा था, what should I write here? क्या लिखना चाहिए? f dash of, what is f inverse x? f inverse x की वैल्यू कितनी है? बता सकते हैं आप? देखिए, ये क्या आएगा पूरा का पूरा? f inverse x is just x raised to 1 upon, so this is equal to n x raised to 1 upon n. See, what is f dash x actually? F dash x is nothing but, where is f dash x? n x raised to n minus 1 dash x is this. I will keep x as it is and I will take n. I will keep x as it is and n minus 1. यहाँ पे देखिए, ये कौन सी वैल्यू आएगी? Let me write one more step so that we will get clear idea. F dash at which point? F inverse x is nothing but x raised to 1 upon. Now what is f dash at t? Can somebody tell me? N t raised to n minus 1. So what is f dash at Let me say this to be t. ये इसका आंसर क्या आएगा? I should write here n t raised to n minus 1, or in short 1 upon n. T is nothing but x raised to 1 upon n raised to n minus 1. See, so this is equal to 1 by n. So what is x raised to n minus 1 upon n? This is 1, n by n, that is 1 minus 1 upon n. Okay, now just if I bring x in numerator, you can write in this way. This will be changed 1 upon n minus. So this is derivative d by dx of f inverse x equal to 1 upon x, 1 upon n, x raised to 1 upon n minus. Do you understand this? अब ये समझ में आया कि नहीं आया? देखो मैं फिर से एक्सप्लेन करता हूँ. ये डायरेक्ट तो आप बता सकते हैं.
यस सर.
डायरेक्ट यहाँ से डायरेक्टली यू कैन से दैट डायरेक्ट मेथड इज दिस. व्हाट इज डी बाई डी एक्स ऑफ f इनवर्स x? तो आप क्या करेंगे? ये 1 बाई n को आगे लाएंगे और x रेज टू 1 अपॉन n ये लाना है हमें. ठीक है, बाय मेकिंग यूज ऑफ इनवर्स फंक्शन. मैंने देखिए यहाँ पे x नॉन जीरो एज्यूम कर लिया है. डी बाई डी एक्स ऑफ f इनवर्स x, ये देखिए क्या हो जाएगा? f इनवर्स x फंक्शन कैसे डिफाइन किया हुआ है? x रेज टू 1 बाय n. ये अकॉर्डिंग टू इनवर्स फंक्शन थ्योरम क्या होगा? दिस इज बाय inverse function theorem. You can write derivative of this function is f inverse x. So what is f dash? F inverse x. What is definition of f inverse x? X raised to 1 upon n. Now let me say this to be t. Then f dash t is equal to n t raised to n minus 1. Now replace t by x raised to 1 upon n. So that same as समझ में आया कि नहीं आया भाई?
यस सर.
अभी ये दूसरा ऐसा लेते हैं एग्जांपल. देखिए
आपकी आवाज फिर से सर.
कम आ रही है.
स्लो आ रही है.
अभी आ रही है ठीक से कि नहीं आ रही है?
हाँ अभी आई थोड़ी सी.
रेडी?
हाँ सर.
ये माइक्रोफोन में कुछ प्रॉब्लम होता रहता है. ठीक है, ठीक है. लेट मी टेक अनदर एग्जांपल. अभी ठीक आ रही है आवाज? अभी प्रॉब्लम सॉल्व नहीं हुआ?
नहीं सर अब आ रही है.
आ रही है ना ठीक से? So let me take another example. Consider function f from minus pi by 2 to pi by 2 to close interval minus 1 to 1 and define as fx equal to sin x. X belongs to minus pi by 2 to we are trying to verify inverse function theorem. Okay, Now what is the derivative of this function? F dash x. Derivative of sin x is cos x. Now cos x is positive if x belongs to minus pi by 2 to pi by 2. ये पता है ना आपको, ऑल एस टी सी. So all S, T and C. So in the first quadrant all trigonometric functions are positive. In the fourth quadrant cos and sec are positive. So minus pi by 2 is somewhere here and plus pi by 2 somewhere here. So if your x is between minus pi by 2 to plus pi by 2, your cos x is positive. Do you understand? Therefore now you can say therefore f dash is positive, therefore f is strictly increasing, strictly positive, therefore f is strictly increasing function. Therefore f is 1 1. And what is range of f? Range of f is equal to closed interval minus 1 to 1 is equal to codomain of f. Okay, so therefore f is 1 to also, therefore f inverse exists. And what is inverse function? F inverse is a mapping from where to where? Minus 1 to 1 to minus pi by 2 to plus pi by 2. Clear? So now let us take our axis between minus pi by 2 to plus pi by 2, strictly less than and f dash x not equal to 0. Okay, and let me take minus 1 less than x. So this implies that f dash x is non-zero. What does it mean? Sin f dash x is just cos x. Cos x is at which point cos is 0? Hmm? So for, let me take,
2k plus 1 pi by 2.
yes, cos at pi by 2 cos is 0. Pi by 2 and pi by 2 we have excluded this endpoints, therefore f dash is non-zero. Do you understand? ये देखिए cos फंक्शन है वो कहाँ पे जीरो हो रहा है, पाई बाई टू पे. ठीक है, तो ये दोनों निकाल लिए है, तो f dash x इज नॉन जीरो. ठीक है, फॉर माइनस 1 लेस देन x लेस देन, ये देखिए इनवर्स फंक्शन, मुझे ये निकालना है. डी आई वांट टू फाइंड आउट डेरिवेटिव ऑफ f इनवर्स x. ठीक है, तो ये देखिए डी बाई डी एक्स, साइन का हम क्या डिनोट करते हैं, साइन इनवर्स एक्स. ठीक है, इसका डेरिवेटिव मुझे निकालना है. आप और मुझको सभी को पता है कि भाई डेरिवेटिव इसका क्या आता है, 1 अपॉन रूट 1 माइनस एक्स स्क्वायर. लेकिन मुझे ये इनवर्स फंक्शन थ्योरम का यूज करके वो लाना है आंसर. ठीक है, तो देखिए यहाँ पे मैं फॉर सिंप्लिसिटी यहाँ पे क्या करता हूँ, फॉर ये एक्स है ना, वो मैं कहाँ पे लेता हूँ, इसका डोमेन क्या है माइनस 1 to 1, लेकिन मैं माइनस 1 और 1 नहीं ले रहा हूँ क्योंकि ये पॉइंट्स के आगे कॉस फंक्शन जीरो हो जाता है, so that will create a problem. Okay, so I am excluding minus 1 and 1, so minus 1. और ये देखिए ये x और ये x दोनों डिफरेंट है, तो ये डिफरेंट करने के लिए मुझे लेट मी राइट डाउन हियर y d by dy माइनस 1 लेस देन y लेस देन 1. ये देखिए आंसर तो मुझे डायरेक्ट पता है कि भाई ये है, लेकिन बाय इनवर्स फंक्शन थ्योरम उसका आंसर कितना है क्या, 1 अपॉन एफ डैश इस पॉइंट के आगे एफ इनवर्स y बाय विच थियरम? इनवर्स फंक्शन थियरम। अभी देखिए एफ इनवर्स y की डेफिनेशन क्या है? व्हाट शुड आई राइट हियर? एफ डैश, मुझे क्या लिखना चाहिए यहाँ पे? एफ इनवर्स y इक्वल टू साइन इनवर्स y, because the reason is this: x equal to sin y if and only if y equal to sin inverse x, or y equal to sin x if and only if x equal to sin inverse y. ये reason is this: x equal to sin y if and only if y, or y equal to sin x. Let me take y equal to sin x. So this is equal to, now what is f dash? F dash x is cos x. So we are trying to evaluate derivative at sin inverse y. So answer of this is cos of sin inverse y. Do you understand? Now we know
यस
that,
सर।
let me say, समझ में आया कि नहीं आया?
हाँ सर।
We know that sin square plus cos square, sin square plus cos square x. X in place of x I will write down sin inverse. What is the answer of this? Sin square x plus cos square x. In place of x I have written sin inverse y. See, here I have written sin in. Let me write down. This is, what is sin square plus cos square? 1. Therefore, what is cos square? Sin inverse y. Cos square sin inverse y, 1 minus sin square sin inverse y. Do you understand? But what is the answer of this? See, sin square sin inverse y equal to x if and only if x equal to sin y. Okay, so this is equal to, can anybody tell me? By the way, what is sin square of sin inverse x? ये आपको इनवर्स ट्रिग्नोमेट्रिक फंक्शन में आया है, sin square of sin inverse x. How can you write this? So this is nothing but sin of sin inverse into, you can write square here also. Do you understand? So now this gets cancelled. Why you can? Because sin inverse is inverse of sin function. Okay, so this is identity. समझ में आ रहा है मैं जो आपको बोल रहा हूँ?
हाँ सर।
ये sin square of sin inverse y, ये कितना हो जाएगा? x है तो यहाँ पे x आ रहा है. देखिए ये यहाँ पे x है तो x आ रहा है, तो यहाँ पे y है तो मुझे क्या लिखना चाहिए? y लिखना चाहिए कि नहीं लिखना चाहिए? Therefore, now let me take under root on both sides. So cos of sin inverse y is equal to plus 1 minus y square. The reason is this: ये है ना, cos is positive in fourth and first quadrant, minus pi by 2, pi by 2. Cos is positive. तो ये देखिए, तो cos of cos, let me say this to be 2, therefore by 1 and 2 we can say that d by dx of f inverse y equal to 1 by अंडर रूट, यहाँ पे देखिए यहाँ क्या है, cos ऑफ साइन इनवर्स y, और cos ऑफ साइन इनवर्स y की वैल्यू कितनी है, अंडर रूट 1 माइनस y स्क्वायर. Sorry, here I should write not x. What should I write here? This is y, not x. समझ में आया ये एग्जांपल? और इन जनरल also we know that by direct method we know that d by dx of sine inverse x, what is the answer of this? 12th में ये आ गया 1 upon अंडर रूट 1 माइनस एक्स. लेकिन ये आया कैसे? इनवर्स फंक्शन है, इसका डेरिवेटिव ऐसे कैसे आप फाइंड कर सकते? ड्यू टू इनवर्स फंक्शन थ्योरम यू कैन से दैट its derivative is this much. Do you understand?
यस
मेरी
सर.
आवाज तो आ रही है ना अब ठीक, कि अभी ठीक नहीं आ रही है?
आ रही है सर.
ओके ओके, ये माइक्रोफोन में कुछ प्रॉब्लम हो जाता है ना कभी कभी, इसलिए ऐसा
नहीं,
होता है.
आ रही है, आ रही है.
अभी देखिए, हम दूसरा एग्जांपल लेते हैं. ऐसे ही आप कॉस कॉस फंक्शन का निकाल सकेंगे. देखिए ये मुझे एग्जांपल लेंगे, दो मैं आपको रखता हूँ यहाँ पे, एक मैं सॉल्व करके बताता हूँ. कॉस, let me take f from 0 pi to -1 to 1, and definition of this function is fx equal to cos x, where x belongs to 0 to pi. Then what is the derivative of f? Derivative of cos function is minus sin x. Okay. So now where x belongs to 0 to pi. Okay. Look at this. We know that for every x belongs to 0 to pi, this implies that what can you say about sine function? All STC, according to all STC rule, in the first and second quadrant, here and here, sign is positive. So multiply by minus, this will become negative. Okay. So what can you say about this? F dash x is strictly less than 0. F is strictly decreasing on which domain? 0 to 1. So f is strictly decreasing, therefore you can say that f is 1 1. And what is the range of f? Also, range of f is -1 to 1. Okay, which is equal to range of cos function is -1 to 1, and which is equal to codomain of f, or you can say that f is onto function. Therefore, f inverse exists. And what is the definition of f inverse? F inverse is a mapping from where to where? -1 to 1 to 0 to pi. Okay. Now what is the definition? Fx equal to y if and only y equal to or x equal to sine inverse. That is y equal to cos x if and only if x equal to cos inverse y. So this is the definition of inverse function. Now let us consider this. Now let me take, see, we will do similar process as we have done in the previous example. So let me take x between, for x 0 less than x less than pi implies, you can see, if x is between 0 and pi, sin x is positive. Okay. The first and second quadrant sign is positive. So therefore for -1 less than y less than +1, let me take y as we have taken here, -1 less than y. We are looking for d by dy of f inverse y. Okay. So what is d by dy of f inverse y? F inverse y is nothing but here cos inverse y. This is just name. You can say also gy. By inverse function theorem, what is derivative of this? Abhay?
-1 upon square root of 1 minus x square.
ऐसे नहीं, मैं आपको वो नहीं पूछ रहा हूँ. By inverse function theorem, what should be the derivative of this function? F dash of
F inverse 1.
f inverse y. What is f inverse y? Cos inverse y. Okay. Now what is f dash x? Minus sin x. So this is nothing but minus sine of, in place of x, I have cos inverse y. Do you understand why I have written like this? Now we know sine square cos inverse y plus cos square cos inverse y equal to 1. We know this identity, okay? Now, see, now this cos inverse y is a member from -1 to 1. This belongs to -1 to 1. Cos square of cos inverse y, you can cancel inverse and this, you will get this as y square. Do you understand? यहाँ पे जो किया है ना हमने, ऐसे ही प्रोसेस है. देखिए, ये मैंने आपको एक्सप्लेन किया था. ठीक है. रीजन यहाँ पे क्या रीजन लिखेंगे? y कहाँ पे है? इसका जो स्पेसिफाइड डोमेन है ना, उसमें होना चाहिए, तो ये आप ये निकाल सकते हैं. तो ये देखिए, so therefore sin square cos inverse y, ये कितना आएगा? 1 minus cos square of cos inverse y. This is nothing but 1 minus y square. Now take the square root so that you can get the value of sin of cos inverse. say this to be 2. The sin of cos inverse y की वैल्यू कितनी आई 2 में √1 minus y square. Therefore by 1 and 2 we get, यहाँ पे लेफ्ट साइड क्या है d by dy of f inverse y. यहाँ पे राइट साइड पे क्या है देखिए -1 by √1 minus y square. ये देखिए अभी अभी तुम बोल रहे थे ना कि भाई cos इनवर्स y का डेरिवेटिव क्या है, दिस इज वेरीफाइड. ये देखिए वेरीफाई हो गई. डू यू अंडरस्टैंड? समझ में आया कि नहीं आ रहा है जो मैं बोल रहा हूँ?
हाँ सर आ रहा है.
11-12 का ट्रिग्नोमेट्रिक याद होगा तो ये समझ में आएगा. सारी सभी चीज़ें तो मैंने बता दी है, फिर भी मैं आपको बोल रहा हूँ. बाद में ये देखिए 10 वाला मैं आपको होमवर्क में देता हूँ एग्जाम्पल. ठीक है, तो कितना है 4th एग्जाम्पल. fx इक्वल टू 10x. उसमें डोमेन कौन सा लेना चाहिए मुझे? What is the range of tan function? रेंज क्या है tan की? अभय,
हाँ सर.
रेंज ऑफ tan फंक्शन क्या है?
8.
यस r है. d by dy of f inverse y by इनवर्स फंक्शन थियरम. ठीक है, देखिए यहाँ पे कैसे करेंगे आप इसका डेरिवेटिव निकालिए. f डैश x क्या है? tan का डेरिवेटिव sec स्क्वायर x, और sec स्क्वायर x तो पॉजिटिव होगा क्योंकि स्क्वायर है. ठीक है, फॉर ऑल x from -pi/2 to pi/2, therefore f is strictly increasing, therefore f is 1 1, and we know that range of tan function is r. Okay, so f is onto also, so f inverse exists. tan का डेरिवेटिव क्या होता है? tan इनवर्स का 1/1 प्लस एक्स स्क्वायर. ठीक है, तो 1/1 प्लस वाई स्क्वायर आपको लाना है यहाँ पे बाय मेकिंग यूज ऑफ इनवर्स फंक्शन थ्योरम. ठीक है, तो आपको यहाँ पे मैंने कौन सी आइडेंटिटी यूज की थी? ऐसा ये यूज की थी. यहाँ पे आप देखिए क्या कैसे ये आता है. ठीक है, यू नीड टू यूज द आइडेंटिटी सेक्स स्क्वायर माइनस टेन स्क्वायर इक्वल टू 1. आपको पता है ना भाई? तो यहाँ पे देखिए क्या आएगा, मैं
हाँ
जो
सर.
बता देता. तो यहाँ पे देखिए क्या आएगा, सेक्स स्क्वायर ऑफ, यहाँ कॉस इनवर्स की जगह पे क्या आएगा? टेन इनवर्स आएगा. क्या आएगा? यू विल गेट सम.
10 इनवर्स.
हाँ, ऐसा कुछ होगा. देखिए ये देखिए इसका डेरिवेटिव तो आपको पता है. एफ डैश एक्स क्या है? टेन का डेरिवेटिव सेक्स स्क्वायर एक्स है. ठीक है, तो अकॉर्डिंग टू इनवर्स फंक्शन थ्योरम ये देखिए मुझे ये निकालना है डी बाई डी वाई ऑफ एफ इनवर्स वाई. तो ये क्या हो जाएगा? डी बाई डी वाई ऑफ टेन इनवर्स वाई हो जाएगा यहाँ पे. तो ये आएगा कितना? 1/f डैश ऑफ एफ इनवर्स वाई. एफ इनवर्स वाई क्या है? टेन इनवर्स वाई है. तो ये क्या है? सेक्स स्क्वायर एक्स. तो सेक्स स्क्वायर एक्स की जगह पे क्या लिखेंगे आप? टेन इनवर्स वाई. सेक्स स्क्वायर इक्वल टू 1 प्लस टेन स्क्वायर, तो ये आइडेंटिटी में ये क्या यूज करेंगे, 1 प्लस टेन स्क्वायर टेन इनवर्स वाई, तो ये क्या हो जाएगा 1 अपॉन 1 प्लस, ये देखिए यू कैन नाउ कैंसिल टेन इनवर्स एंड टेन, वाई बिलोंग्स टू कहाँ पे है, डोमेन रिस्ट्रिक्ट कर दिया है, ठीक है। सो यू हैव गॉट द आंसर, ये सॉल्व कर दिया मैंने, लेकिन आपको ये चीज़ लिखनी है पहले, ये सब है ना, 1 1 कैसे 1 2, ठीक है, लिख सकेंगे।
हाँ सर।
बाद में ये एग्जाम्पल देते हैं। इनवर्स फंक्शन के लाग्रांज मीन वैल्यू थ्योरम, कुछ एग्जांपल्स लेते हैं। अभी लाग्रांज मीन वैल्यू थ्योरम आपको पता है ना, लेट मी टेक सम एग्जांपल्स बेस्ड ऑन दैट थ्योरम। Verify Lagrange's mean value theorem for the function x is equal to x cube minus 3x square on the interval that x belongs to 1 to 4. Let's solve this example. See, here our function f is from where to where, close interval 1 to 4 to r, and fx is defined by x cube minus 3x square, x belongs to 1 to 4. You can now note that f is continuous. What is derivative? F dash x is equal to, what is derivative of x cube? 3x square minus 6x. X belongs to 1 to 4. Now f is continuous. On this closed interval, f from open interval 1 to 4 to r is differentiable okay. Therefore, by Lagrange's mean value theorem, there exists some c belongs to 1 to 4 such that f dash c equal to f4 minus f1 upon 4 minus 1. That is f4 minus f1 upon 4 minus 1 is 3. Okay. Therefore, now see what is f dash c. So 3c square minus 6c equal to f4. What is f4? यहाँ पे कितना आएगा देखिए 48 माइनस 24 माइनस f1 कितना होगा 3 माइनस, ये कितना आ गया देखो 24 माइनस, तो ये वैल्यू कितनी आई 9. तो 3c स्क्वायर माइनस 6c minus 9 equal to 0. Now divide throughout by which number I should divide, Abhay? Do you hear me?
3. Yes sir, 3.
Yes. तो यहाँ पे देखिए फैक्टर लेते हैं c minus p and c plus. So what are the values of c? C equal to 3 and minus 1. Note that there exists c equal to p which is between 1 to 4 such that f dash c equal to f4 minus f1 equal to 4 minus 1. यहाँ पे मुझे c निकलना चाहिए, c मिलना चाहिए, then only Lagrange's mean value theorem is verified. तो समझ में आया कि नहीं आया एग्जाम्पल?
Yes sir.
यहाँ पे मैंने मिस्टेक कर दी है, आपको कुछ पता भी नहीं चला, देखा? आपको भूख लगी है, मुझे ऐसा लगता है। यहाँ पे देखिए f4 माइनस f1,
हाँ सर।
ये क्या आएगा? f4 की वैल्यू एक्स क्यूब माइनस 3x स्क्वायर, तो 64 माइनस ये कितना होगा देखिए 48, एक्स क्यूब माइनस 3x स्क्वायर है ना, ये हमें कंसिडर नहीं करना है। और इफ यू टेक x इक्वल टू 1, यहाँ पे क्या आएगा 1 माइनस, ये क्या हो जाएगा देखिए, कोई बता सकेगा ये कितना आएगा? 16। तो ये बाई चांस ये C1 और 4 के बीच में आ गया। यहाँ पे देखिए यहाँ क्या आएगा, ये वैल्यू कितनी होगी आपकी? 16 प्लस 2 तो यहाँ पे देखिए 3c स्क्वायर माइनस 6c माइनस 6 इक्वल टू 0। ये क्या डिवाइडिंग बाई 3 यू विल गेट, यहाँ पे देखिए c इक्वल टू माइनस b, तो दिस इज प्लस 2 प्लस और माइनस अंडर रूट b स्क्वायर माइनस 4ac, तो दिस इज 4 प्लस 8 अपॉन 2। ये वैल्यू आपकी क्या है? c की वैल्यू समझ में आया? तो दिस इज c इक्वल टू, so this is nothing but 1 plus or minus root 3. So 1 minus root 3 is a negative number, but 1 plus root 3 is positive, and which is belongs to, root 3 is 1.73, something like this. Lagrange's mean value theorem is verified. So we stop our discussion here. Next time we'll see some new examples. Okay. तो समझ में आ रहे हैं एग्जाम्पल्स आपको?
हाँ सर।
क्योंकि अगर आपको थ्योरम के स्टेटमेंट पता होगे ना तो ही ये एग्जाम्पल सारे समझ में आएंगे, ठीक है? अदरवाइज यू कैन नॉट अंडरस्टैंड द एग्जाम्पल। So goodbye.
गुड बाय सर।